Welcome back to my channel Bal Vigyan Bharti. Here is your mentor Avilash Sarkar, and we are progressing on speed, time, and distance subject. We are solving some problem, and till now we have reached the problem number 11. Now we'll proceed to the problem number 12. So the problem number 12 says a man covered a certain distance. A man covered a certain distance at some speed had he moved 3 kilometers faster, had he moved 3 kilometers per hour faster, okay, he would have taken 40 minutes less. He would have taken 40 minutes less if he had moved 2 kilometers slower. If he had moved 2 kilometers per hour slower, he would have taken 40 minutes more. He would have taken 40 minutes more. Okay. Find distance. Okay. So a man covered a certain distance. Let's say the distance. Let the distance covered be d at some speed, and speed be s. Okay. Had he moved 3 kilometers faster, then for first case the assumed speed is equal to s plus 3. Since I am assuming that units are the same as given in the sum, other part of the sum. Okay, so that if it is 3 kilometer per hour, s is also in 3 kilometer per hour. Okay, there is no ambiguity in that. He moved he would have taken 40 minutes less. So in that case, the first case, time is what? Distance upon time, and distance upon speed would be the time. If he had moved 3 kilometers faster, he would have taken 40 minutes less. So this would be the distance are same, speed is s plus 3, and this is the new time, and which is a lesser time. That means this plus 40 minutes, 40 upon 60, I am converting it into the hour. So earlier time is more, as because our speed has increased. So this time, this speed, the earlier speed minus, actually the equation should be this, will be written in this form. The earlier time minus this time is equal to the difference, because he is taking less time. So this is lesser value, this is higher value, and difference is this one. So ultimately this will become 2 by 3. This is your first equation. Okay, this is equation number 1. Let me simplify further. D I am taking common, s plus 3 minus s, and s into s plus 3, this is equal to 2 by 3, which implies s will be cancelled out, 3 will be there. So that means d upon s into s plus 3, that is equal to 2 by 9. So this will be the first equation. Remember this. Okay, other part I am just deleting. There is no need of the other part. Okay, and the second case 2, where you would have been means moved with 2 kilometers slower. So that means speed, second case speed will be how much? S minus 2. So time this case will be taken higher. So distance is d, your speed is s minus 2. This is the time for second case, and the earlier time was d by s. So this case, this is lesser, this is higher, and you would have 40 minutes more. So that means instead of putting this first and putting the second and take it a minus, as I know that in this case the time would be taken more, so I am just reversing the situation and putting as it is 40 by 16. So difference from the higher to lower will be the difference. What is the difference? More or less, that depends on which one is higher. So I'm accordingly I'm keeping the things in place. So definitely this will give you the correct result. So d, if I take common, s minus s plus 2, here earlier case it was 3, okay, 3 I have transferred here, okay, fine, by s minus 2 into s equal to 2/3, 2 by 3. So now s cancelled out, ultimately 2d is equal to s into, so if I want to write this two equation, the first equation is d upon this one, the second equation becomes d upon s into s minus 2, that is equal to 1/3. Okay, so this will be the case. So now I rub everything here. I would write only the equation d upon s into s plus 3 is equal to 2 by 9, and d upon s into s minus 2, that is equal to 1/3. Now divide this two. This is first one, this first one. So 1 divided by 2, you will get s will be cancelled out, dd would be cancelled out. Only thing will remain as s minus 2 by s plus 3. Okay, as because I am dividing 1 upon 2, so 2 by 9, 1/3, to 2 by 3 will be there. Fine. So now solving this, 3s, 2s means s, 3 to the 6, 6, 12. So s is equal to 12. Okay. So what you have taken speed, actual speed is 12. Now he would have taken 40 minutes. So find the distance. Now if s is being found, so what would be your distance? Any of the equation you can use to solve it. So distance is equal to 2 by 9 into s is equal to 12, 12 into 12 plus 3, 15. So that is equal to 3 3 is 3 4 3 5 5 4 20 40. So distance is 40. Now it is in kilometer, so I will write in kilometer. Fine. So distance is 40 kilometer. Moving to the next calculation part, I will do faster, because that anyhow we can able to do, you can practice at home for faster calculation. There is no much clarity is needed to solve the calculation part. That is your own skill, you can develop of your own. There is no analytic method to solve the thing, so I am not very much wasting that time. So the next one is, it takes 8 hours for a 600 kilometer journey. It takes 8 hours for a 600 kilometer journey if 120 kilometer done by train, if 120 kilometer done by train and rest by car and rest by car, it takes 20 minutes. It takes 20 minutes more if 200 kilometer is done by train and rest by car. Find the ratio of the speed. Find the ratio of the speed of train to car. Okay, now it's very easy. What we have to assume ratio is train is to car. This is the ratio of the speed. T is denoting the speed of the train. C is denoting the speed of the car. Okay. Now it takes 8 hours for a 600 kilometer journey if 120 kilometer done by train and rest means for 600 it is 480 kilometer done by car. So their speed is t into, so tx speed of train and that of car is c into x, because there must be one common multiple. I am taking it as a x. So multiplying with x, it gives a speed of the train, and multiplying with x with c, it gives the. So the if 120 kilometer done by train and the total journey is 8 hours, the first equation will be how much? So 120 done by train means with the speed tx, distance upon the speed, it will give time, plus 480 by cx. Okay, that will give you 8 hours, because everything I am taking the same unit, hour everywhere. It takes 20 minutes. This is first equation. If it takes 20 minutes more, means if it is 8 hours for first case, it will take 8.2 8 hours 20 minutes more if 200 kilometer done by train and the remaining is 400 done by car. It takes 8 hours and 20 minutes, 20 upon 60. So that means 1/3, means equal to 8 into 8 upon 1/3. This is the second equation. Okay. Now from these two you have to solve the equation, or else because we are getting two equations now, so there are three unknown t, x, and so instead of that if I take instead of the ratio, if I want to reduce one variable, so straightway I will take the speed of train is t and speed of car is c. Once I will get the result, I can make a ratio, so there you can reduce one variable. So this will be only t and c. So now see the equation is reduced to two variables. Okay, now solve it. So how will you solve that? You can reduce it by dividing with 60. So that will reduce the thing 60 or 120. If I reduce the 1 by t, if I divide throughout by 120, 1 by t plus this is 4 upon c is equal to 8 upon 120. So this can be reduced up further, because numeric part you can solve, the variable part. So this also by 200 if you reduce, so this will be 1 by t plus 2 by c, that is equal to 8. These are 25 by 3 into 200. So this can be reduced further. 200 this is equal to 8 no 5 so 1 by 24, and here 8 ones 8 8 8 5. This will be the reduced form. Now from this two equation, if I deduct, so 4 by c 2 by c, so 2 by c ultimately equal to 1 by 20, 1 by 15 by 124. 24 minus 15, that is equal to 4 5 9, and here it is 15 into 24. So c is equal to 2 into 15 into 24 by 9. 3 3s are 3 5 3 8 8 by 40 80. So c is 80. So the car speed is 80 kilometer per hour. Okay, and that of t is equal to, if I put 1 by t there, so c is equal to 84 by 4 by 80, that means 1 by 20, 1 by 15 by 1 by 25 by 5 by, so 5 will there, 15 into 20, and that too is equal to 1 by t 15 into 20, so that is equal to 360. So t is equal to 60 kilometer per hour. Now the ratio of the speed of train is to car is equal to 60 is to 80. So that is equal to, if you reduce by how much, 20, it will be 3 is to 4. So this will be the answer. Okay, understood? Because this is the main equation. If you can establish this, then solving is your own part. Okay, so I'm moving to the next problem. 14. In covering a distance of 30 kilometer, in covering a distance of 30 kilometer, slowly I will go on, means a tougher problem. So be alert and be attentive to the class, because the process I am solving, that will fetch you to the problem where more tougher problem can be solved with this concept. If you can understand these concepts, then further problems can be easily understood. So kindly follow all the classes, all the problems. Okay. It would be very much tougher in the later stage, that's for sure. So be attentive. So in covering a distance of 30 kilometer, Abhay takes 2 hours more than Samir. 2 hours more than Samir. If Abhay doubles his speed, if Abhay doubles his speed, then he would take 1 hour less than Samir. Okay. What is Abhay's speed? What is Abhay's speed? So in covering a distance of 30 kilometer, Abhay takes 2 hours more than Samir's speed. Let speeds are I am assuming our speed is represented by A and Samir's speed is represented by S with their initials. So that will be very easy to remember. So in covering a distance of 30 km, Avoid takes 2 hours more than Samir. So this first segment is saying कि the distance is 30, Avoid takes 2 hours more. So what Samir takes? So Samir is taking less hours. So the distance is 30. If I divide with the Samir's speed, so this is the Samir's time. Okay. Plus 2 hour if I add, I will get Avoid's time. This is the Avoid's time, which is 30 upon the Avoid speed. So Samir's speed, Avoid takes 2 hours more. So Avoid is definitely 2 hours more means if I add the time of Samir plus 2, I will get Avoid's time. That's for sure. So this is your first equation. In second part, if Avoid doubles his speed, then he would take. So only Avoid is making his speed double. So Avoid's speed is 2a then. So if it is increasing, so definitely you will take lesser time, less time, 1 hour less. So in this case, Samir's speed is same. So this time is same, and this time Samir speed time is more than Avoid's time by 1 hour. So this would be the second equation, because Avoid's time is less by doubling his speed. So this speed is what? Samir's time minus 1 if I do, whatever time Avoid is taking, that much time. This is the equation. So I think it's very easy to solve. I am leaving it to you. I am not going into that solving part. So you can solve yourself. Okay. So I am moving to the next problem. Problem number 15. It is a very long problem, so I will write very small letter, small size of the letters. A man who is 2.4 kilometer away, a man who is 2.4 kilometer away from a car start running further away from car at a speed of 2 meter per second, and car takes 75 seconds to catch him. A train would take 15 seconds to cross the same man if he was running away from the train. If he was running away from the train at a speed of 2 meter per second, and if would take 16 seconds to cross a 60-meter long platform, find the time taken by the car to completely overtake the train. Overtake the train. Fine. There are so many information. Let me take one by one. The first is a man who is 2.5 kilometer away from a car. So let me take the man's position is this, car's position is this. This is car, this is man, and in between distance is 2.4 kilometers. So I am making it in meter because other information I am seeing it in meter. Okay, fine. This okay. Omkar, start running further away from the car. If car is here, man is here. Let me check. If the initial distance is away, means the man is moving this way. Okay. So after moving some distance, let's say here the car, the initial distance is this. This has moved by a distance x. Okay, the man's speed is 2 meter per second. This is information is given, and when the car is catching the man after 75 seconds. So let's say the initial distance is this. After that he has moved away from the car. So this x distance will be how much? So x is equal to the distance before the car catches him. This is the point of catch. So from here to here, this will be moved by how much? 75. This must move because the initial distance is 24. Then he started moving. So after that, car has chased him and catched. So in 75 seconds, it can move another 150 meters. So this is x is 150. So what is x plus 2400? This is equal to 2550. So this is the distance car has to move to catch the man. So for the speed of the car, from there you can calculate how the distance is this much, and speed it is taking 75 seconds. The same time he will reach from here to here. So car speed is 2500 divided by 75. It will give the car speed. So this is how much? 25 102 25 3 34 meter per second. So this one part is over. Now this is a train would take 15 seconds to cross the same man if he was running away from the train. Now that with respect to the train, man is moving away. That means if train also, if I assume moving, what we can say, the train also moving and the man also moving. The man moving away from the train. That means train can move this way and he is moving this way. So if it is the case, then train will never cross the person because that distance will go on increasing. What is the possibility when train can cross the man? If man's direction already I know, this is away from the other, so train must move this direction only, otherwise there is no possibility of train to catch the person. So the train would take 15 seconds to cross the same man. So train also is moving this direction. So if I assume that 15 seconds train in whatever position it is there, the initial distance is not there, but thing is that if I consider means individually the train when it is crossing a point, means person's width or length with respect to train is negligible, so I am not considering any length to add on to the train. The train crossing a point is only when he is crossing his own length. Okay, so if the point is standstill, the train would cross starting from here to this, the length of the train. Understand this very point. Length of the train will be cross a standstill point when it is crossing its own length, and that is taking 15 seconds. But this point is not fixed, it would move certain distance when the train just catch the point, let's say, to cross it. Until it crosses that whole length, we will not say, by that time this point also started moving and this also moving. Okay, so what would be the time taken to cross the person? As because we understand they are moving in the same direction, their relative velocity is what? Speed of train minus speed of man. This is the speed, effective speed it will take to cross how much distance? The distance of the train length. Otherwise we can take in other way also, you can take how much point is moving in 15 seconds and how much distance that is added to the car, the length of the train in 15 seconds. That will give the train speed. Both way you can do. What I mean to say, actually when this is a standstill, train will move the length of its own. Let's say length of the train B is equal to L. So now if the man is standstill, the length is this by 15 would give you the speed of the train. This could be the possibility, but this point is moving in the same direction the train is moving. So that means this has caused another some distance in that time the train is crossing. So how much distance is added to it? It is 15 seconds into the man's speed is 2. That whole distance, when it is divided by the time of their crossing each other, will give you the train speed. This is the one method. Or else, if I say the relative velocity between the train and the man is what? Speed of train minus speed of man, because they are moving in the same direction. This is the effective speed into the 15, that will give you the distance traveled, and the distance traveled is what? When train is crossing the man, the distance traveled is equal to the length of the man. So this will be the case. Either you can use this thing or you can use this thing, that will give you the same meaning. Okay, how I am saying, see how this and this are same. This is what? The speed of man. Now see, I am converting it. 15 into Sm plus L is equal to 15 into St. Now take this part this side. So what would be? 15 is common. Sm into 15, that is equal to length. Now see, this I am getting the same equation. So that is being replicated. If I say the relative velocity of the two moving part in same direction would be minus. If they are moving in the opposite direction, that would be taken as plus. In opposite direction or moving towards each other. If they are moving in the same direction, their velocities will be minus. If they are moving apart or moving towards each other, in both case you have to add the velocity. Remember this. This is very tricky one. So ultimately, either of the way you can use. So from there, this is the equation. Now length of the vehicle is what? St. The train speed you know? No, you don't know. The train speed you don't know. Let me. This is 2 into 15. This is your first equation. Okay, fine. Now second case, this is, I'm just rubbing it out to understand. I've taken. Okay, this is first equation. Second equation is saying when if he was running away from the train, the speed is okay. If would take 16 seconds to cross a 60-meter long. Now the train, another condition, a train of length L crossing a 60-meter platform, that means this has some length with respect to the train length. This has some length, this is not negligible. So if the train is crossing the platform, the distance it will travel, the length plus the 60, this is the actual length traveled. By the time, if I say the 16 seconds is taken to cross the, so this is distance upon time, that is equal to the velocity of the train. Fine. So this st can be used here. So length, if I put this st here, so st is equal to what? Length plus 60 by 60 minus 2 into 15. From this is your second equation using here. So now if I reduce it, this will be L by 60 into 15 minus plus 1 minus 2 into 15. So that ultimately this will be minus 15. This is 15, 15, 15, 4. So this is equal to L. So L minus L by 4. What I have done? L plus 6 by 16, not 60. Sorry, I have made mistake. This is too much of calculation, no? Okay, fine, no issue. So what I'll do, this 15 I will take this side, L by 15 I'll do, that will give you L by 16 plus 60 by 16 minus 2 and 32, 24, 24 by 16, 24, 34, 60 minus 32, 28, sorry, 28 by 16. So if I take it this side, this will be 16 minus 16 minus 15, 1 L, L upon 15 into 16. So this is equal to 28 by 16. So 16, 16 be cancelled out. So L is equal to 28 into 15, that means equal to 120, 12, 52 is 30, 42, 420. This will be the length in meter of the train. So this is also another information. I will write it down. Okay, so this length of the train is 420 meters. So out of this equation, now find the time taken. Now understand, train is moving in the same direction, car is moving, because they are both chasing the man. Now how much time car will take to overtake? Now car is not overtaking because the car speed is 34 and train speed we have not calculated it now. So let me take the train speed. So train is covering L plus 60 in 16 seconds, that is your st. So length is already known, 420. So from there 420 plus 60 by 16 is equal to st. So st is how much? 480 by 16 and 30. So the st is equal to 30 meter per second. Now we have to conclude something. What we have to conclude? The train speed is lesser than the car speed. The car is moving this way, train is moving this way. Okay, so that means if car has to overtake the train, so that means train is somewhere before the car. Otherwise there is no question of, because car speed is more, car may cross train anytime. The train train will never catch the train and catch the car. So train position from this perspective, we can understand train is somewhere here in between the car and the man. So okay, if that is being concluded as because car has to completely overtake. So car to move overtake in same direction, their relative velocity between the car and the train is what? 34 is the car's speed minus the 30. So this 4 meter per second will take to cross when and with respect to the cars with trains with cars also we can take negligible. This car is very small, train is very long, so in that case also the car will overtake the train. Now I put this train here, otherwise this will be confusing. Now a car is trying to overtake the train, so only with this relative velocity he has to move how much? The train length. Train length is what? 420. So time that has to be calculated is 420 meter is covering with a relative velocity of 4. So that means how much? 4 ones are 4, this much second. So this will be your answer. Okay, this is very tricky, but you have to be very calm and cool while you are calculating with so much of information and data. Okay, so this will be your ultimate result when this will cross, the car will overtake the train completely in 105 second. Okay, so I will end up here because this is very lengthy episode being done, so you must have some time to watch all the sums that I have solved for you. So thank you for now.